Hi, my name is Fred Chung, part of Android Developer Relations. Today, we're going to talk about Bluetooth Low Energy. In Android 4.3, we are adding built-in platform support for Bluetooth LE. The new Nexus 7 and the Nexus 4 are the first two Nexus devices that are going to be Bluetooth Smart ready, making them capable of communicating with the many Bluetooth Smart peripherals on the market today. I'm going to do a sample app walkthrough today. But before doing that, I'd like to walk you through some technical concept of Bluetooth Low Energy so that you can make sense out of the API objects. As its name implies, Bluetooth Low Energy uses less energy as compared with Bluetooth Classic. It is not uncommon to have Bluetooth Low Energy devices that last for weeks, if not years, before needing to recharge or replacing the battery. The protocol itself is optimized for small bursts of data exchange, which is ideal for applications such as sensors, remote controllers, so on and so forth. In contrast, Bluetooth Classic quite often is involved in high bandwidth applications such as audio streaming. Now, let's have a look at how information is structured in BLE applications. BLE is based on a specification called General Attribute Profile, or GAT. It governs sending and receiving of short pieces of data known as attributes. The Android app can be either a GET client or a GET server, depending on the application. The GET server can support a collection of services. You can think of services as different features offered by the device. Each service is uniquely identified by a UUID referenceable by your application. Under each service, there could be a collection of characteristics which you can perform read or write operations depending on the BTLE profile you're working with. To put things in perspective, let's have a look at the heart rate measurement profile, which is one of the standard profiles. The heart rate sensor is the GET server. The Android app in this diagram is the GET client. The GET server hosted on the heart rate sensor device offers a number of services. Under the service, there's a collection of GET characteristics. There's one for providing heart rate measurement, which you can receive notification on, one that indicates the location of the sensor, which you can read from. Now that we have some basic understanding on Bluetooth Low Energy technology, let's have a look at some code. Let's first take a look at the Android manifest. There's a new feature called Android.hardware.BluetoothLE. You declare it if your application would only work on devices that has that feature. You can omit it if your application would work on a device without that feature, so that you can optionally disable the Bluetooth Low Energy features within your app. Now the debugging session is up. I'm going to go ahead and click scan. So I've put some breakpoints here. What it's trying to do is to call the start LE scan method call. And as you can see in the API documentation, a lot of the BLE operation methods are asynchronous in nature. You have to specify a callback such that when interesting events happen, in this case when devices are discovered, the callback methods are invoked. So I'm going to let this breakpoint go. As you can see in the app, it's able to find a couple of devices. Let's go ahead and click on heart rate sensor, which corresponds to the test kit that I'm trying to test with. So let's go ahead and click on it. Now it brings you to another activity which is bound to a background service. And I've put a breakpoint in the service. What it's trying to do is to connect to the GET server that's hosted on this device by invoking this method called connect GET. Just like the previous example, since all APIs that have to do with BLEs are asynchronous in nature, you have to pass in another callback here. Now that we've connected to the GET server, it's trying to invoke this method called discover services by trying to discover the available GET services hosted on this device. Let's go ahead and release the breakpoint, and now the callback on services discovered is invoked, meaning I have found, the app has found the services that are available on the device. The app's gonna iterate through the the collection of services found and display on the UI as seen here. Since this is a heart rate sensor, we're gonna do some heart rate measurement. Let's go ahead and locate the heart rate service, expand it, and you'll see heart rate measurement characteristic. Let's go ahead and click on it. What happens is that since it knows that the characteristic supports notification, it tries to enable the notification. So let's go ahead and release this breakpoint. Now, as soon as it begins getting heart rate updates reading, you'll get this callback on characteristic change, indicating that you are receiving a notification. So we're going to go ahead and release the breakpoint. As you can see on the screen here, we are receiving heart rate measurement readings in this very, very tiny text. I don't know if you can see it, but it's updating with heart rate measurement notifications receiving from the peripherals. Now, I want to illustrate a very important point, and that is whenever you are done with a particular Bluetooth LE connection with the peripheral, you should really call this close method so that the stack can do its cleanup properly. That's it for the walkthrough. If you want to learn more, do check out the Bluetooth Low Energy Developer Guide on d.android.com. Thank you for watching.